It's Monday, May 18th, and today on Machine Learning in Production, I'll be trying out the TensorFlow Extended SDK to deploy a pipeline to AI platform. Here we go. Hello and welcome to Machine Learning in Production on Adventures in the Cloud. My name is Yufeng Guo, and today we're going to be checking out the TFX SDK. For those of you who are new, Machine Learning in Production is a series of videos providing a behind-the-scenes look at the process of building out machine learning and data infrastructure. The goal is to build with real production-grade tools and encounter the kinds of challenges that real-world engineers like yourselves will face. Along the way, we'll encounter everything from data storage, web development, networking, security, scalability, and of course, machine learning. So be sure to subscribe to catch the channel. Be sure to subscribe to the channel to catch all of our episodes live, and let me know about the exciting machine learning work that you're doing. In terms of what's coming up, on Wednesday, we'll be doing our next episode of the Data Show with Felipe Hoffa. It's a really exciting one, all about BigQuery. It's going to be a really epic event. We've already got over 500 RSVPs on Meetup, so we're really looking forward to that. It's going to be a special kind of day with BigQuery. We're going to have a whole bunch of guests, and yeah, it's going to be really, really interesting. Then we're off on Friday and the following Monday for the Memorial Day weekend, so just 2 live streams this week. And next week, we'll have Wednesday and Friday with Dina Graves-Portman and then Zach Akil, some colleagues of mine who will show us things about building kind of production monitoring pipelines, and Zach will give us another one of his epic machine learning whirlwind tours. So with that all set aside, let's dive into today's topic. TensorFlow Extended, or I'll just refer to it as TFX for short. So let's see, what I've got today is, the other branch of the kind of guide that we were playing with on, what was it now? Last Friday, yes. And on Friday, let me move over to our coding view. We were looking at these 2 workshops, right? It was all about kind of Cape pipelines, and we did sklearn on Kubeflow pipelines. We were in this folder, and so today we'll be in its sister folder in the TFX branch of that. So I'll paste that into the live chat now for all of you. Today's repo. There you are. And let's see, we will basically kind of take a look at some of this, and then we'll kind of spin up a similar notebook as we did last time. One thing that I'll point out that's a little bit different is that the notebook environment that we're using this time is similar but not actually identical to the previous one. So if you're kind of following along, you'll want to notice that this is all the same. We're still setting the same sort of project and APIs to be enabled, and same kind of enabled. So if you did it last time, these are all the same and you don't need to do them again. But you'll notice here in the instructions for creating the notebooks, the pipeline is the same, and in fact you can reuse the same pipeline, which is exactly what I'll be doing. But in terms of the notebook, you'll notice that it's calling for a TensorFlow Enterprise 2.1 no GPU image instead of the base CPU image that we used before. I think this is a really good suggestion, because what we end up doing is they actually included an installation script which looks something like this and handles a lot of the kind of library installation for Python, as well as installing kind of a scaffold, which is a tool we'll be using for building the container images, and installing some Jupyter extensions to be enabled. And so that sort of stuff is happening here rather than building a custom container like we did last time, which kind of took a while. And so this ended up being a lot faster to get up and running. So we can see the VM that I'm using here. Go back to this. Let me move this over so I can see the live chat in case folks have questions. And yeah, so this was the notebook from last Friday. Here's my Jupyter Lab environment that we'll be using today. And so I've got it kind of open. I was playing around with it a little bit earlier, And so we got our notebook, and just to review kind of how I navigated there, we'll see that when we, in the kind of steps, we'll go back down to where we were in the steps. Where were we? So saying, create this notebook, and then clone the repo. So since it's a new notebook, you'll have to reclone the Git repo and execute that installation script. And then from there, it's off to the races. We can jump into one of these labs. And so I've already run the installation script. The way you would want to go about doing that is kind of hitting this plus button. Usually that's already hit for you, and selecting terminal down here. And so that will give you a terminal to work with. And you can see at the top, that was one of the first things I ran, was install.sh. I'll make this a bit bigger and at the sacrifice of screen space. And that installed all of these libraries that we needed. And so let's go back to the notes here. So now we'll go on to this first lab. So today we'll cover these first two labs, which in the first one, it's kind of a live walkthrough of the steps of this pipeline that we'll be building, which can be visualized something like this. And then the second lab will deploy that workflow to a pipeline. Now I've actually got that running right now, and it has barely underway. It appears like it's barely underway, when in fact it's been running for almost 3 hours now. I am not entirely sure if it's stuck or if Dataflow is just deciding to take an eon, but the good news is running the steps manually proved to be reasonably efficient and snappy, and we were at least able to get through to the end of kind of the workflow and see results in that first lab, which is good. So with that all out of the way, let's go into the first lab. So this first lab is all about talking about the components of TFX and how to kind of use them in a way that kind of helps us understand what they do and how they are wired together. I found it to be really helpful for really getting hands-on and mind-on wrap around all of these different TFX components, because there's a lot of components that they recommend you have an understanding of, and it can be a little bit overwhelming at times. So let's see, when we're first dropped in here, you'll be in kind of the home directory, which will be here-ish when you start, and then you'll cd into the main directory, and so you have to kind of click through the sidebar, and so you can see the path that you'll be wanting to follow at the top of the GitHub link. And so you'll go through and hit up the navigate your way into workshops, and then into TFX Cape TF21, and then we want to go to lab 1. And so then once you open up this notebook, we'll be dropped into a IPython notebook like so. And the important thing is, when you do this, what you'll notice, in fact, is even though we just did this, we're actually not actually in the right view, because there's a step towards the bottom. The TensorFlow model analysis visualizations won't render properly in JupyterLab. And so as a result, it's better to run this notebook in what's called Jupyter Classic Notebook. So for those of you who have been using Jupyter for a long time, you may remember that it used to be that we would run, Jupyter Notebook, and then the directory or the name of the notebook file that we're running. And so that was kind of the recommended way of running Jupyter. Now we have JupyterLab, which is much nicer. However, it seems that there are some things that we have to run in classic notebook mode. And so that's up here. You have to go to help. I actually didn't know about this until I saw this note. I've always wondered about whether there was some direct connectivity here. And so you can click launch classic notebook, and it'll actually launch it properly with the proper qualified URL and everything, which is really quite nice. I'm glad that works. But the downside is we need to navigate through this file structure again. So MLOps on GCP, workshops, TFX, Cape 2.1, lab 1. And here's our notebook, so we'll click that and let that open. So now we're in a new state. Everything is loading, and I haven't run anything kind of pre-run or anything like that. So you're going to get to see this truly as it happens. I'm going to close out of the instance of the notebook here, which I may live to regret because I don't know that I saved everything, so that'll be fun. And let's get started. So this works with a similar kind kind of data set as we saw on Friday, the cover type data set, which is aimed at, you're supposed to infer what the kind of tree cover type is. And so we'll run this. What's interesting, it looks like the kernel was preserved, because when I ran this, it's 66. So we'll see what how that plays. But they recommend kind of checking to make sure everything installed okay. When I first ran this, I forgot to actually start a new notebook instance. I was using the old one because I just looked at the instructions carefully and was like, oh, it looks like it's the same one. So I'm just going to use that. And a bunch of stuff wasn't installed, of course. So then I was like, what's going on here? So if that's the case for you, make sure you go back and make sure you have the right virtual machine instance that you're connecting to. So we're expecting to see these values roughly, and we do. I'm not sure. Oh yeah, this is the DLenv TensorFlow enterprise version. And if they don't match, you can run this to manually force the right versions to be installed for each library. Mine seem to be correct, so I'm going to leave this cell unrun. Then we want to run this configuration settings value, and this is going to kind of point us at local artifact store and serving directories. If you remember from Friday, there's this notion of an artifact store path. Typically, we would point that at a path on cloud storage, something a little more permanent than the local hard disk of our notebook, our virtual machine. But in this case, because we're basically in prototyping or experimental mode, this is appropriate. Then the data set lives here on Google Cloud Storage, and so we can just point to that and it'll pull that when the time comes. So now we get to our first kind of step or piece of this workflow, is creating that interactive context. And before we go forward, I just realized I can toggle a few of these things. Toggle that, toggle toolbar. Yeah. All right, that'll give us a little more headroom to work with, which will be nice. And yeah, so this context is what will enable us to run things in an interactive manner. And so there's a couple of optional values. These are actually all optional technically. We've chosen to kind of name our pipeline, even though it's just going to be for kind of tracking purposes. And so this gives us this context variable, and we'll be using that context variable over and over again. And it also builds for us a local SQLite database, which is stored, kind of as a file on our local disk, because we said the artifact path, this artifact store path is local, so that's where it stores. So if you had one in cloud storage with, you could back it with a MySQL database, for instance. So I think we ran that, maybe we didn't, we did not. So we'll run that again, make a new context, and the first kind of TFX component that we're going to explore is called example gen, and it's all about generating examples. I'm not in love with the naming schema, but that's a personal issue. It generates examples and it takes in kind of the raw data and it turns it into TF records, which is kind of or TF examples, which is what TensorFlow takes in as its kind of chosen format, its custom, efficient, easy, good for streaming format. And it also takes care of our splitting of splitting into train and eval. Now, when I first ran this, I'll run this now, it gives you an interesting warning when you run context.run. So this setup, you'll see here, we have these two splits, and you'll see they're pretty deeply nested library calls. We give them a name and we say it's a 4-to-1 ratio. So hash buckets 4 versus hash buckets 1 kind of is to achieve that 80-20 split. And then with CSV example gen, it's like a subclass, basically a specialization of example gen, and it is specifically for CSV files. And so then we can give it a name of our choice, point it to this external input is, show you where that is. So it's a utility that we imported, and it's just a wrapper around the name of the file where it lives. So data root was that GCS path, which we configured up here. And so that's just a wrapper around that path to kind of set up the GCS file handlers and things like that. And we give it this output configuration, which is this variable right here. And we can then get our data split and processed. So the nice thing about this is, whoops, onto another tab. This is all we need to have from a coding perspective to take care of grabbing the data set, converting it into TF records, splitting it, and then having a place to pick it up. And from that perspective, it's pretty handy. There's typically going to be more code than that for kind of pre-processing your data. Not pre-processing, but like loading your data set can sometimes be a bit more tedious. And so it's nice to see that they have created a nice wrapper for this. So once you do context.run, remember context is kind of our live interactive pipeline or execution environment. And we do .run, we pass it example gen, which is, where did it go? Oh yeah, here it is. Example gen is that variable that is our component, our instance of that component. And check out this output statement. It's really interesting. So this format with these dots in front of it is actually a very nice description of how you can navigate the kind of object structure / tree, if you will. You'll notice in the next line of code in the sample, it says example gen.outputs bracket examples.get bracket 0.uri. And it's, when I first saw this, I was like, how on earth am I supposed to know that's what is needed, right? Like, okay, example gen dot, I'll just wrap it in dir and try to like search through it, but like this is your answer right here. You've got all the parts listed out. And so this is the inputs and outputs. You can check out all these values. So let's take a look at that, right? You can do example gen, and I can basically use this as my guide for navigating. Of course, I just made it smaller. Navigating the tree. So I can do execution ID, and it'll not work because I haven't tried that before. So that's brilliant. CSV has no attribute execution ID. Good stuff. Okay, apparently I can't do execution ID, but I can do inputs. And then you can see this first, what's the first thing in inputs? It's bracket input. So bracket input, right? That should exist. And you can see that it's just a sub component. Now I can expand this. You can see that this is the same as this piece. And then I could potentially do something like input dot, and so what I'm concluding here is that aside from type name, of course, exists as just external artifact, which is not the most interesting thing in the world. This part here, it's underscore artifacts, right? So that means it's supposed to be a private variable. You can access it if you want, but if you look at the example here, the way they're going about it is you can use this .get to get us that internal. So it's the same output as running underscore artifacts. And so what else was there? So artifacts, and then there's this bracket 0. So it looks like this could be an array of many artifacts, each of which contains a bunch of stuff. So we do get, and then we say, let's leave it blank now. And you'll see the array, and we need to just index into, you can see the bracket here. And so we just need to index into that. And then there's type name and URI and ID, right? So we can still see the nicely rendered version here, type and ID. I thought there was another one there. What was the other one? Get bracket 0. Oh, it still shows it. If I take away the bracket 0, it shows it like that. Type name, URI, ID, bracket 0. Type, oh, there's no type name. I guess it's here. And then so there's type. Oh, there's no ID. That's what's gone away. Interesting. But yeah, then you can write .uri, and you can get this path of where did the inputs to this component come from, right? And so this is how you would do that. And similarly with outputs, I'm just gonna copy this in because that's the only change you have to do. We can see that this value, this is a local path as we would expect, because that's where we said our artifact store was. And so we're gonna store kind of these outputs, these intermediate outputs between one component and another. We need somewhere for the data to go, for the next one to pick it up. And usually it would be cloud storage, but in this case, we're doing it on the local disk. Okay, so this next step grabs those, and then this is kind of a clever, well, sort of clever move. They did OS join on the examples URI that they just grabbed, /train, and then each of the names for which they did a list dir of everything within the train directory. So those are all the TF record file names. And then they created a TF record data set this is just to list out the thing. And so they did dataset.take2 and then pulled an example and kind of parse it out. So just so we could see the data as it's loaded into the TF record, and then we unload it just to see that, like, okay, it is loaded the way we thought it was. We can unpack it, and we can kind of use this to do a little live debugging to see what the values are. And so we can introspect into this and be like, okay, this looks reasonable. These are the values we expect. Which brings us to the next component, statistics gen. This is all about coming up with the data statistics, which can be then kind of pushed into downstream components. Let me pop over to, let's see, maybe I think the GitHub one doesn't visualize the image for some reason. The image, yeah, it's this image. Well, no, there's no. Where's the high level image? Here. So example gen we just went through. And then we're going to go into statistics gen. And as you can see, statistics gen will be wired to a couple other things. And this will generate stats about our data set, which we can kind of validate against things. And schema gen, which we'll see shortly, tries to automatically infer a schema from the stats and from the data set. So statistics gen is connected to example, as I mentioned, and you're going to begin to see how each of these components start looking kind of similar to each other with just their names replaced, right? They're all TFX.components, and it was example gen before, and this is actually shorter than the other one. We say that the examples are coming from the previous components outputs, right? So that's why we say example gen.outputs at examples, and you'll recognize this call as the first part of what we were using right here. Example gen.outputs.example, and just to take this away, you'll remember that this was something like this. And so these are our artifacts that are being output, and you could potentially have other artifacts as well. So you could have outputs and then some other stuff here, depending on what you have in that component. So we run that, and now we have our familiar friend, this execution space, and again we have inputs and we have outputs, and we can see that this one is kind of, what is the input? It's an artifact of examples, right, from the previous one, which we can open, and we can see it was living here, which is the same path that the previous thing's examples came from. So I'm going to close that, and then the outputs of this are some example statistics, which, whoops, made it small, which live kind of at this path here. You can see it's stats gen, statistics generation, statistics. So a lot of these folders are very deeply nested, and you're not necessarily intended to go and dig through these folders manually. My understanding is that the intent is for us to kind of use the tooling to view all the data inside, and the tooling knows how to navigate these folders appropriately. And so we can run context.show to get something meaningful out of the outputs of this statistics gen file. And so again, we see, we're passing in its .outputs, and this time it's statistics, not examples. But we didn't need to go and kind of dig into statistics outputs, right? Outputs, statistics, and then all of this kind of deeply nested thing, and then kind of finding the URI and then going into that file. We didn't have to pass that in at all, really. We could just pass in this top level value, and it knows what to kind of dig in through and grab. And so we have a UI that's kind of, for those who are fans of the facets tool or the what if tool, you'll recognize some of this. Unfortunately, this is a case of ridiculously nested scroll bars. So when I get to the bottom, you'll see there's a scroll bar here, which goes this way. And then when I go up, once I get over to the side, you'll see there's a scroll bar in that vertical scroll bar, depending on where my mouse is. So I can scroll here, or I can scroll here, which is fun, they say. So one of the things that I noticed, is this kind of highlighted red value. You're like, oh no, there are 36% of these values are zeros. What a disaster, right? But in fact, the cover type is a numerical enum, it looks like. The min and the max are 0 to 6. And it looks like it's actually just a bunch of values, like 0, 1, 2, 3, 4, 5, 6 are the values. So that doesn't seem as egregious as it may at first appear. And you'll notice that there's a set for training, and then there's also a eval split with a similar set of statistics that are generated, assuming I can scroll successfully. There we go. We have a couple of different directions there to deal with. So that's our statistics gen, which then of course leads us to the schema gen, as I alluded to earlier in this bit here, right? We have this schema gen. We've got a lot more steps to get through. Whoosh. All right, so this is basically looks the same as before. We're going to take the statistics gen's outputs and pass them in as the inputs of the statistics gen or schema generation. And schema generation is all about kind of inferring a schema, and it's not going to be perfect every time. And you're going to need to potentially adjust something. So you can see the inferred schema looks something like this. They're just kind of, all right, we got some strings, we got some integers. Here are some of the strings that it's literally the same as the feature name. So, and then we have some that are categorical values, and that's those two, and it shows all the distinct values. So we might consider updating some of these values. You know, for example, we knew that cover type is 0 through 6, 1 through 7, whatever, you know, however it's coded, and then apparently slope is supposed to be 0 through 90, and so we can load that schema file into schema by, you know, passing in this path. And again, here's an example where we are digging into the URI manually and kind of getting this path just so we can pass it directly into the TensorFlow data validator. That's what the DV is. And then we can use that to use the kind of API to set domain for this schema in the cover type category. And we can give an integer domain from 0 to 6, and then in the other case 0 to 90. And so once we're done with that, we can display that schema just like we did, well, differently from we did, I guess. We used this to display the schema this time, and we see that these values have been updated at 0 to 90 and 0 to 6. And so then we can write that schema back into the artifact store in the place where we know it's supposed to be kept, right, in this schema directory. And so now we have this long schema file, which is kind of the stringed out version of the kind of summary we saw earlier. And so now we get to import that schema into what's called the importer node to import that external artifact, including the schema file, and that will allow us to use it in other parts of the workflow. So all of this kind of this side path over here is so that we can load the schema. There should really probably be an arrow that goes this way from the schema gen to the importer node, because I don't know that we've done stuff with the example validator quite yet. So we'll run these two, which take the you know, you'll see here there's the schema directory, there's it's a type schema, so it's grabbing the schema, kind of loading into there, and then we'll grab it out from the schema importer later from basically all the places that are reading from the importer node. So the example validator, the transforms, the training will all read from this import node. And so you can think of it as kind of like everything we did before is almost like scratch work of like, okay, what's our schema supposed to be? Okay, well, we're referring this, let me tweak it this way, store it back in, and then when we're ready, we hand it to the importer node, which then says, okay, this is our kind of golden copy that we'll use in the next following steps. And we can see that, okay, this schema importer did import it correctly. We had our two additional changes are loaded in. Great. And so now we want to go on to example validator. This compares the data set, the actual kind of eval data set in this case. It only looks at the eval split. To the generated and tweaked schema to make sure everything looks right. And it can do a number of different other things, but basically it's searching for anomalies in your data. And so we'll run that, and we'll you know, we can take a look at the file that gets generated. It's going to look pretty similar to the schema file that we saw before. And what we're going to actually do is compare this to basically the data, and so you can run this output and visualize it, and we can see that there's no anomalies found, so that's great. And there's kind of other labs and stuff we can dig into more to look at how to use this validator in more depth, as well as the cases where there are discrepancies and how to deal with that. So this brings us now to the transform, which takes inputs, a couple of different inputs. We're really starting to wire things together now. We have our example generation and Oh, and just looking over at the live stream. Hi, everybody. Papu Kumar Pashi says hi, and Danji says hi. Hello, everybody. Thanks for tuning in. We're at the halfway point now, and so from a time perspective, I don't know. Well, we're also kind of halfway on the notebook in the scroll bar here, but so this transform component is for taking your input data and transforming it, right? There's typically some pre-processing steps that need to be done, and we want to make sure we can reliably do that with our data. And so because of the fact that we have that schema kind of defined, it means that we know what we're going to be dealing with when it comes time to do these transformations, and that's really important. So there's a pre-processing module that's already been defined. I'll show it to you here in lab 1. There's this preprocessing.python file. The notebook like cats it out, which is like it loses syntax hiding everything, so it's not really nice to look at. So there's a library called TensorFlow transform, often abbreviated in Python as TFT. And what it'll do in this case, we're using it to fill in some missing values. We're gonna do a little bit of scaling and apply kind of categorical vocabularies to those categorical features after we fill in the missings, and return that. So it's not like too much heavy processing. It's really intended to just show us what it looks like. I'm gonna comment out that line just to save us on space there. And so running this, transform wants to see, let me run that while I talk about it, wants to see examples, a schema, and a transform, right? So that's that Python file that we had up here. And so we need to give it the examples that it's going to be using. We need to give it the schema. And so you see this is our importer, right? It's not coming from schema gen. Transform is reading straight from this import node. And so that's kind of an important note there. We only use the schema gen to generate us a schema, and that's why there's nothing really wired to this, is that the schema generates a file, and then we kind of played with that file and just manually loaded it into the validator and import nodes. So that's run, and so this transform is a lot of outputs, but basically the output components we can see here are a couple of folders. Apparently it's not done running yet. Is it done running yet? All right, it just finished. Metadata, transform function, and transformed metadata. And it should have operated on both the train and eval folders. And so you can see, again, we're using this nomenclature of the component.outputs and then some dictionary lookup, basically, of whatever the inside the name of it was, right? So transform graph, why is it the string? Why is the string? Why is the string called transform graph? I'm actually not sure now that I look at it. We didn't really give it a name, so that's an interesting kind of side effect. It might be just the default name, and you could potentially give it other names, but a lot of times these are kind of hard-coded. So for the transform component, it's going to do these two, transform graph and transformed examples. Luckily, we have this visualization, so we can very easily see what it's supposed to be and not have it kind of fall apart on us. So let's run this. We've got our outputs. It's going to do another kind of read through, just like we did with the original data set. But you'll notice now the data is different, right? They're not just the simple numbers. We've scaled everything from 1 to 0 using the range, and we're not 1 to 0, but like on a smaller axis. So that's an important thing for deep learning. You typically don't want large values, large absolute values, because on an absolute scale, it can really screw with their numbers, because inside of a deep learning training code, it's all multiplications, right? So you start multiplying triple-digit numbers, double-digit numbers together, you get huge, it blows up is what happens. And so you want to use decimals with high precision. So now on to training, the often the star of the show, but as you can see, it took a while for us to even get to this stage, and that's kind of the point. The training component is something that is kind of at the center of it all. It gets all of the attention. So you can see here the trainer, and if I zoom out, but you can see it's surrounded by all of these other components that are working. And so let's go on over to kind of see how everything comes together into the training, and then it kind of opens up again. So training takes in the transform, of course, and that's where the data is as well. So the data is flowing through the transform component into the trainer, and so that's why there's no example gen component wired directly to the trainer here. And so in terms of the other pieces, it also needs the schema again and the code. So we can see here we have our model.py. I'll look at that shortly. And we have a number of different values here. So I'm going to run these cells because the training takes a hot second to complete, because we're doing 5,000 steps. So there it's going. And let's now look at this model.py file, as well as looking at how these components are wired together. So in model.py, it is a wide and deep model using Keras. And you can see here we have a couple of hard-coded values here. The notable one here being hidden units being 16 and 8. It's a 2-depth neural network, and the batch sizes are both 64. So there's a couple of utility functions which are really just like wrappers to a few large calls. There's an input function that takes care of taking the transformed value and making a batch data set for it to consume. This is the core of it, building this Keras model. It has some numeric columns and categorical columns. For those of you who have seen the kind of classic wide and deep examples with the census data set, this will look kind of familiar, of mapping. That's why there are these for loops rather, that are mapping all of the columns into categorical and numerical feature columns. And at the end of the day, we create this wide and deep classifier with the wide columns, the deep columns, and in this case, they are kind of manually implementing that in Keras. So there's more code to it with input layers and such. So we can potentially spend another hour exploring this on a separate live stream. But the long and short of it is that there's deep layers that they've made, and it's done some clever things here with like embedded for loops and using the functional style of Keras to be able to allow us to be quite flexible in defining the structure of the network with those variables that we saw at the top of the file. And then the wide layers, and then combining them at the end. Where is it? Here we go. You concat the layers, and then we have our models. Compile the standard calls, and then it will print the model summary. We'll look at that at the output, and then it runs. This run function is passed to the TFX trainer component, which calls all the functions above it, including the creation of the TF out transform, the data set, building the model, and then there's a couple of TensorBoard callbacks so that we can visualize the training, which we'll check out in a sec. And we call our fit. There's training serving, and then we save out the model at the end. So that's a super whirlwind tour of this file. Definitely take the time to read through it if you're interested in kind of seeing the more details about how this is implemented. But once we have this model file, which is passed in here, then we want to, let's see, there's a custom executor spec, which is this generic executor. So that's kind of boilerplate. And then we have our transformed examples, right? That's the transform thing. We have our schema. This is our schema importer. So this diagram probably should have said importer node, not schema gen, right? This is our importer node. And we have our transform outputs, the graph. So we have transform.outputs examples and transform.outputs the graph. Maybe they should be closer together. They're separated by the schema. And then we have our two arguments here about the training and eval args, one for the number of steps for training and another for the number of steps for evaluation. And so our training has completed while we were away, 5,000 steps. And the numbers aren't really that important here. We got a loss of 0.64. We got accuracies around 70-something%. But more importantly, we executed this training on the local machine in this kind of context, and we have our output, we have our model, right? And we have these inputs that we put in. So this is outputs.model or .outputs bracket model, and we can visualize this in TensorBoard. I don't know why these big buttons are down here. That's kind of weird. Can I resize the window to make it go away? Apparently I can't. That's cool. Next up, we're going to try to see that training output. So this is actually kind of interesting. We can print out a couple of things, and what we want is this path of all the logs. So I'm going to copy that. And we need to open this in a separate JupyterLab terminal window. And we can do that in the classic environment or in JupyterLab standard. So I already have that open here. And in fact, I loaded this earlier. I don't think I revoked the auth, so we'll see what happens here when I, oh, I just pasted the path to the logs. What I actually want is this, right? So I'm gonna paste this up here, and then I wanna copy this. So this is gonna upload, oh, what just happened? TensorBoard.dev is a kind of online hosted TensorBoard. And we need to upload our logs. So that's TensorBoard.dev, well, not .dev, but dev upload. And we're going to upload that to TensorBoard.dev. Now we'll be asked to authenticate to TensorBoard at this stage. Though I think I did that already. And it's a simple, it shows a URL, and then you copy that URL over and then select an account. It's like what you get when you connect like a third-party system. So I'm going to paste that in. That was the old graph. This should be our new one. It shouldn't look that different. You can see our accuracy curve. So this is just as an example of just like, you know, it wrote it out. We could load it into TensorBoard. We can see it. And in fact, this is, I want to say public. So if you want to play around with this TensorBoard graph, feel free. TensorBoard, there you are. And so let's see, where were we? That's TensorBoard then. Yeah, and so it takes a second to kind of upload it all, and once it's done, we can kind of press Control-C and close that out. And so let's see, where are we in our plan? We're still on training. We've got to move on to evaluation and a couple nodes at the end here. So what do we got? We have the evaluator. This evaluator will use TensorFlow model analysis to take our examples and compare them to our previous models. Now we don't have any previous models, so I guess maybe this time I will, because I had one from, you know, when I was testing this. But this is not the evaluation step that we think of around the training and evaluation, quote unquote. That already happened. It happened in the trainer. And so this evaluator is trying to take the output models of the trainer component and record the evaluation metrics so that it can, in the future runs, look at more training outputs, more models that are being trained, and say, is this model better than my old model, or is it worse? And whichever one is better, it will get blessed, in this case, to be deployed. And so the configuration here is to say that the latest blessed model kind of resolver, this is what it's called, this is a resolver node, to pick the previous model to compare against. And so this is kind of a weird thing where you have to write the resolver node before you can write the evaluator, because you can see here the evaluator is a dependency, or the resolver node is a dependency of the evaluator, right? The evaluator has the trainer input and has the resolver node input. So we need to write the resolver node or create it first. And so you can see this sets it up. It passes in what's called a channel. It passes in a resolving class, the latest blessed model resolver. And you can see there's a model and a model blessing. And so this initializes all of that. And so we can see the model resolver is empty because we don't have anything yet. And we can now run the eval. So you can see here the eval config is this piece. So when I run this, it will take a bunch of metrics. There's like thresholds for certain values that we care about. So this is an accuracy threshold, our lower bound and upper bound of accuracy. And we have a change threshold of like how much is counted as like, oh, this is different versus like a tie. And of course there's a direction. Higher is better, lower is better, things like that. And then we have our metric specs, which is our sparse categorical accuracy, which is the metric we care about in this particular case. And we can basically, you know, pass these into this eval config, right? So we have our metric specs here. We have our accuracy threshold somewhere. Where did that go? Oh, that was passed into the metric specs itself. And then we have, we can basically have this output for this spec, which we can then pass into our evaluator at long last. So we have our examples. We have our model. We have a baseline model coming from the model resolver. What's interesting here is that we're calling these with dots instead of the previous format of, you know, having it be like that. I'm not sure why that is, and I wonder if we could have been using this format the entire time. And if so, I am just a little bit upset that we weren't, because this is way nicer to look at. I think what I'd like to do is rewrite this with that version and see what happens, because what could go wrong? So let's run I'm gonna say this is model annihilator other. This way we can do, wow, that was terrible. That. So I'm just gonna change 1 in this case just to see what happens. If I run this, it seems to be okay with it. That is crazy. Okay, so that just like upends everything to some degree, right? Of like, we could have been doing this all along, instead of doing this, much more kind of typing intensive. It works fine. Oh my goodness. Okay, so if I do this and add now dot run, this same arguments. What too many curly braces. Evaluator object has no attribute run. Okay, so it seems like it's not quite working. I'll keep playing with this. It's interesting that it even it did an error before. But let's move on in the interest of time. So we have our 2 components with our evaluation and the blessing, and we can see here that it just outputs a file that's called blessed versus I guess not. And again, we can see that it does this outputs and then dot blessing versus, this is crazy and really a bit of a game changer, right? If we can index into all this without using the bracket notation, whew, that'd be real nice. And we should definitely do that going forward. Now this is the piece that I haven't done before because I forgot to run this in the right place last time. And so it says, as it says, right, these visualizations don't render. So, presenting for the first time this TF model analysis output. Let's see what it looks like. So it's going to run this, and wow, it's something. It's one of those things like, and it's a what is this? So we got an example count. We have 20,000 examples. It looks like we can move this slider. There's a slices overview and a metrics histogram. So if folks want to see anything in particular, just say something on the live stream and I will happy to click around and try to figure out what is happening. Number of weighted slices? What is this about? It's very unclear. Let me see what this next one will render. Apparently it renders nothing. Render slicing metrics, render slicing metrics. I don't know why this one won't show something, but the other one, oh, there we go. It wasn't showing something. Okay, so this is wilderness area cache, Comanche, Neota, and Rawa. So there's like 4 different wilderness areas, and there's counts. I don't know how this is really relevant to a, ooh, it changed. So if I move this threshold, if it's higher, it'll cut these low ones away, which are only 1,300 and 1,000. So I could cut 1 away here. And then if I want to cut 2 away, I can do that. But I'm not entirely sure what this does for us. But what's interesting is how much this changes, right? These two look like they're really similar, but I guess they're not as similar as we thought. Because 8,000 versus 8,000. Oh, it's just zoomed in because the range is now 8,800 to 9,000. So it's like super zoomed in. So the difference is accentuated. It's decided to reset the y-axis. Interesting. Anyhow, next up we've got the infrastructure validator, which I don't know if it showed it here. It's kind of in between steps. This is a really nice thing. It allows you to basically put the model in a playground that mirrors your real production serving infrastructure so that you can make sure that it is working, so you don't deploy something and just cause everything to fail. So you can see here, it what does it say here? It validates, once we validate the performance with the evaluator component, this infra validator is only validating kind of the infrastructure and that the model is compatible with that infrastructure. So it says it's able to generate predictions from served model in the environment configured to match production. And so this config takes a model and the examples and launches the model in a sandboxed TensorFlow serving model server, TensorFlow model serving server from the latest image in a local Docker kind of engine. And so then it can check that everything works, including kind of querying the model before really saying this is good to go for production. If I remember correctly, what this will do, you can see it in the outputs here, is it will actually create a Docker image, like legit, spin that up, load everything in, and run it. So that takes a hot second, and I'm wondering if we have the time to do it. I guess we should, otherwise we won't have the next step available to us. Well, we will, because it's like kind of a side step. If we put it in here, what it would look like is it would be kind of the evaluator would point to a infra validator right here, and then this would still be here. So the pusher is just a wrapper to push a model into production. So you just say, push this into production, done. Oh, it finished. Did it? Maybe. Okay. Infra blessed. Cool, it did finish. Oh, because I think because I built the image before, it didn't have to like rebuild it from scratch. The first time I ran this, it took a little while. So now we are deploying the models with this pusher, right? It checks whether a model has been blessed, and if so, deploys it by pushing it to model to the model to production to the kind of designated location. So you can see the infra validator and the evaluation come together, and we can see this. Oh, there's another opportunity. It's actually just .model, same thing, and we can really confirm that by looking at this hex code. Put that there, put that here. Same place, same thing. So I'm starting to think that anytime you see this syntax in the context of TFX, we can save ourselves a couple of key presses by doing it that way instead. So we've got trainer outputs, and we even see it here. The trainer outputs model it's bracketed, and I would have to assume that we could even do this blessing. Yeah. So that all works fine. And then we have the output of this push. So we can see that the pushed model, did nothing happen? Generating, maybe because I did it too many times. Push model, artifact, push type. The concern here is that the URI is blank. Let me just take a quick glance at, do we have the notebook open? Like, what does it look like in the UI here on GitHub? I don't think they show any outputs. They didn't save the outputs. So it is up to us to make that display, but it will not cooperate. Well, it might be a display issue. So let's see if it shows something. We want to make sure the path includes the local TFX environment, which I've ran before, so it might have just double included it. It's fine. And so this is our big model push, right? So this is the model that we've saved. It's rather long in terms of the signature, you know, a long list of inputs because it's a big, it's a wide kind of table. And we have 5 minutes to go. Oh my goodness, there's a second lab. All right, I will just talk through this briefly. I've run it before, so at least we'll have the outputs. We won't have to wait for that. So in the second lab, lab 2 in this folder, it basically takes all of these pieces and wires them together properly into a pipeline that can run on Kubeflow pipelines and on AI platform pipelines from an infrastructure standpoint. So I'll highlight some of the high-level notes of like what we needed to keep in mind. So, whoops, that's the wrong tab. Still the wrong tab. Okay, so what they've done here is in lab 2, they have a pipeline folder as a subdirectory. There's no other files, and you can see in here there's a bunch of Python files. So they've taken a lot of the code, pre-processing, the model, the features, all that have been separated into individual files so that they can be passed in for all of those components that we're using. So there you can see a description of all the different pieces, you know, what logic each file is implementing. So then we're going to build and deploy that pipeline. Here we I've chosen to try to go through the agony of sorting through how to properly load this URL in. The main thing I want to highlight here is that it's supposed to start with hosted KFP default. and it needs to not have the trailing slash included in it. Otherwise, you will be sad, as I was. And so that's why I have this ridiculous bracketing just to drop the trailing slash. If you run this command, and you can see I piped into grep, so you do gsutil-ls, list all of your buckets, and I was like, well, things that start with exactly that are the only ones I care about. And so I can grab that, and it'll be only one thing, hopefully. And then I strip out the brackets, I strip out the trailing slash, and I'm off to the races. Previously, you can just copy paste it and put it in the string, like it works fine. Yes, I can also use regex to do that. You're really got at, so Tibor asks, you are really got at talking and interacting with the lab at once. Oh, thank you. And then we have the GCP region. The endpoint is that URL from before. That's this path right here at the top. I think you can see that. Yep. And you know, they do a similar trick to grab the project ID, which again you can do manually. The final things I would highlight here is there's a bunch of environment variables that they've kind of included. You can pretty much just take it as it is. We won't have time today to kind of go through all those individual things. I'm thinking we might record a separate session where we talk about this lab and the lab 3, since I'm only going to be able to cover this lab in brief. And it's pretty straightforward. Like, much of it is just waiting for things to run. There's a couple of TFX command line things that you can do. There's TFX compile, so that compiles the the TFX library into a kubeflow YAML. So if you remember from Friday, kubeflow builds everything to a YAML. So this is the file that comes out. You can see it's something like this. It's a lot cleaner than I would have expected. Oh, because the image is in a Docker file already. And so then when we deploy it, we want to do TFX pipeline create. And this takes a while. Once this runs, future updates are faster. You can run pipeline update. You can see it passes this custom TFX image, which is what we set here. It's the project ID and pipeline name. We actually saw it in this YAML file. It's this. This string right here is what's constructed. And then once everything's compiled and you've pushed everything, so you can see this is what it pushes, or this is what the output is when you deploy it to a pipeline, and then you will be able to see it here. There's our pipeline, and I've got an update, right? I did one, then I pushed a new update. And then when you want to run it, what happens, what you do is you say TFX run create, passing in that pipeline name and the endpoint. The endpoint, again, is just this URL. And then it creates that run. You can list runs, and it has this ridiculous, because I'm so zoomed in, it overflows and stuff, so it looks ridiculous here. Your run ID, if you want to do a status, TFX run status, this run ID comes from either here when it comes out, it says list, and then run ID, and you know, because of my formatting, it's this string right here. You'll want to make sure you're careful not to take this string right here, because sometimes it's different. And I got bitten by that. The other way you can do it is you can go to experiments and go to all runs, or click TFX cover type and go to the specific run you care about. And you can see there's still no ID, not yet. And when you're in here, you can, I thought there was a way to see the run. Terminate archive. Oh, snap. You can't. Okay, run output. Maybe it's in here. Weird. Okay, so I'm hoping it's just this. But I thought that didn't work for me. I tried that, but I could be mistaken. So is this the same string as what I have copied? It's not quite the same, right? So using that run list, the ID is truly supposed to be kind of an identifier. And so the URL, I think, probably encodes it differently. And so that's basically it for this second lab. It just runs, it just executes, you know, the existing code. So much of the time in understanding this lab comes from looking at these files, and so that is really what we did earlier just now, right? We understood the contents of these files because this is just encoding the same sort of stuff that we saw. You know, this is the model.py. It's literally the same code. And so by running it in that interactive mode, Lab 1 provides a deeper look into how to use TFX specifically, whereas this second lab is all about how to get it onto the pipeline, and the discussions are more around the gotchas of working with the pipeline and things like that. In terms of my own kind of experience here, my main note is that I want this compile step to be able to run not on my local machine, but on Cloud Build. That would be really nice. Because this is running in the VM, and then it's dependent on the size and bulk of the VM. And really, because we're running everything as jobs anyway, I would love it if I didn't have to have a powerful VM to do this, since this is all going to get kicked off into the cloud as jobs to begin with. Yeah, so Adelaide says, yeah, good idea to have a short video to show this, to show kind of this second lab. So thank you for that note. I'll definitely make a note of that and try to make something work for that. But generally, hopefully that sort of at least made some sense, these two labs. And, this pretty much wraps it up for today's live stream. We'll be back again on Wednesday with the data show. Myself and Felipe are prepping for that. Really excited for that episode. It's going to be all about BigQuery. And specifically, we are bringing guests. It's going to be a bit of a special event, let's say, a special day for BigQuery, as the title is right now. And there's going to be, some special content that we are eagerly preparing for that. And so be sure to catch that, 3 p.m. Eastern, noon Pacific. And Adelaide says it made sense. Thank you. That's good. I'm glad that's making sense for you all. And yeah, with that, I will bid you adieu for now, and we'll catch you on Wednesday.